Okay, so number 10, we're identifying and graphing each of the following conic sections. So we see this one if we look at our formulas. Notice how it's got the form of the ellipse and the hyperbola, but both are added, so it's an ellipse. So it is definitely an ellipse. And then now we need to graph it. Well, what we need to graph it is we need the center. And we know we get the center from the opposite of those 2 points. So we got the point -3, 4. So we go to -3, 4, our center. And then we need the radius in each direction. Remember, this is the radius in the x direction squared. This is the radius in the y direction squared. So we know Rx is going to equal 6, and Ry is going to equal 3. So we know we can go up and down 3, and left and right 6. 1, 2, 3, 4, 5, 6. If we went 2 more. 1, 2, 3, 4, 5, 6. Okay, so there's the basic shape of our ellipse. Okay, there's our ellipse. And then I'm going to plot my foci on here too. So remember, for the foci, we've got, for this one, we got Ry squared plus L squared equals Rx squared. So we have 3 squared plus L squared equals 6 squared. 9 plus L squared equals 36. Subtract 9, we get L squared equals 27. Square root that, and we get that L equals the square root of 27, which is approximately 5.2. 5.2 there. So we know we go 5.2 left and right from the center to get to our foci. So 1, 2, 3, 4, 5.2. And 1, 2, 3, 4, 5.2. And there is our ellipse. Alright, next we've got number 11 here. So it looks just like the ellipse, but notice how this is a subtracted term, so that makes it a hyperbola. So we got our hyperbola. So we know that we need a center of our hyperbola. It's basically just like the beginning is just like drawing the ellipse. So we go, notice how the x is second. So we say -2, +1 for our center. We know this is Ry squared there, and this is Rx squared. So we know Ry is 4 and Rx is 3. So we can go ahead and plot those points to make our box. So -2, 1. So we're right there. And we go up and down 4. 1, 2, 3, 4. 1, 2, 3, 4. And left and right 3. 1, 2, 3. 1, 2, 3. And we use this to make our box around this. So there's our box, where we put asymptotes through the box, through the corners of it. So we have asymptotes through the corners of our box. And we know, so finally, we know because y is the one that is positive, we know our curve is connected to the points that were up and down, your Ry, rather than your Rx. So there are hyperbolas there. Now we can find the focus. Remember, it's Rx squared plus Ry squared equals L squared for this one. So it's 4 squared, or 3 squared, plus 4 squared equals L squared, and we know that's Pythagorean triple, so it's L equals 5. We can also find that by computing it. So our foci are here and here. So we label those little F's for foci. And again, it was here and here because we counted 5 in the same direction as our hyperbolas. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there we go. that's how we graph our hyperbola. All right, next we have number 12 here, which, if you recognize, is a circle. So we've got, this is a circle. So we know that the center of this circle is at -4, -3. And we know this is the radius squared. So since r squared equals 16, we know that r equals 4 if we square root both sides. So center -4, -3, and a radius of 4. So -4, -3. So there's our center. And then we go 4 in each direction. 1, 2, 3, 4. 1, 2, 3, 4. 4 and 4. That's going one more unit in that direction. And there we go. And there's our circle. All right, so there's our circle. It's graph, center, radius. We're good to go. All right, on to number 13. Okay, so this is number 13. So we've got 12 times x plus 5 equals y minus 3 squared. So we've got, so 12 represents the 4p. This is a parabola, since only one of the terms is squared. So 12 represents the 4p. So 12 represents the 4p there. So that means if 4p equals 12, and we divide both sides by 4, we get p equals 3. I know y is squared, which must mean that our parabola has to go either left or right, one of those two. But since p is positive 3, we know it's the one that goes to the right. So from our vertex, which is kind of like the center of the other ones, we have our vertex at -5, 3. Remember, always get your vertex from the x. So make sure you're getting the x coordinate from the x, y coordinate from the y, because they're not always in this xy order. All right, so -5, 3, there's our center. We know p is 3, so that means since y was squared, we go p to the right to get to our focus. So there's our focus. There's our vertex. And technically you go 2p in each direction. So 1, 2, 3, 4, 5, 6. So you go 6 that way, and 1, 2, 3, 4, 5, 6. And those connect to your parabola. So there's our parabola. And the only thing we're missing is our directrix, which remember is on the opposite side of the vertex from the focus, equidistant. So we're going to go one more unit because we got to go 3. 1, 2, 3. And it's a line that makes it t with the direction, if you were making a line with the focal length, makes it t with it, it's perpendicular to it. So our directrix is that right there. And if we were asked for the equation for it, it'd be x equals -8. Since you went 5 to the left, you went 3 to the left from -5. And there we go. And that's our graph. Okay, so now we're finding polar coordinates, 3, 4. So we want polar coordinates. Let's say we want this in radians. You need to be in radian mode. But you should be able to figure this out based on what we know about polar coordinates. Well, the polar coordinates of 3, 4. So I'm asking for this in radians. So polar coordinates of 3, 4. Well, we know 3, 4 is right here. 3 right, 4 up. There it is. There's our point. So instead of going 3 to the right and 4 up, we want to find the r and the theta that would take us to that same spot. Well, we know r is this. And how would we find r? Well, we use Pythagorean theorem. 3 squared plus 4 squared equals r squared. So we know this is a Pythagorean triple, so r equals 5. So that works. R equals 5. Now for theta, we could simply use trig to set up to find this theta right here. Because remember, this theta right here represents the angle from this quadrant, from the first quadrant. It's like that unit circle angle. the angle measure from the positive side of the x-axis to the radius, wherever it ends up being. Okay, so we know it should be something between 0 and pi over 2. So you make sure you're in radian mode in your calculator, since we want this in radians. And we say, all right, tan theta equals 4 over 3. So we say theta equals inverse tangent of 4 over 3. Making sure you're in radian mode of your calculator. Inverse tangent of 4 over 3, enter that in. And we get theta equals 0.927. So our final answer for this is 5, 0.927. Now if I'd asked for degrees, we would have put it in degree mode and done that same thing. If I'd asked for it in degrees, so we would have done that same thing and we would have gotten 53.13 degrees. So theta for degrees would have been 53.13 degrees. And you could have said your answer to be 5, 53.13 degrees. So this would be for degrees, that'd be for radians. Okay, so now we want to find the rectangular coordinates of -3, 3 pi over 2. Well, a negative radius does something special. I'll remind you of that. But first, let's find where 3 pi over 2 is. So again, this is r comma theta. We want to find x comma y. That's what we're trying to figure out. So essentially, all you really need to do is visualize where you are. So there's a couple ways to do this actually. You can use the simple formula, x equals r cosine theta and y equals r sine theta. If you're in radian mode, you can do that. Now, I prefer a more logical method that allows us to have some confirmation of where we are. So first, so we want the x, y for 3 pi over 2, -3. Well, 3 pi over 2, remember, is right here. So that's 3 pi over 2, this angle. But a radius of -3, so a radius of 3 would take you right down there to that point. But a radius of -3 goes 180 degrees up to the opposite side of the circle. So it goes 3 pi over 2, but then the fact that it's -3 makes us flip over to here, and then we go +3. So we know we'd be up there, up 3. So 1, 2, 3. And the coordinates of that are pretty easy to find. It's just 0, 3. So we know that's our answer because there's no angle formed there. So we know it's just 0, 3. The radius is pretty easy. Now, let's confirm it using our formula. So if we do, in our calculator, if you plug in x equals -3 cosine 3 pi over 2, you'll get -3 times cosine 3 pi over 2, which is 0, so you get x equals 0. And that's exactly what we got. If we do y equals -3 sine 3 pi over 2, you'll get that it's 3, because sine 3 pi over 2 is -1. You get that y equals 3. And notice, that's the same exact formula we got, or the same exact coordinates that we got with our logical method. So either way you slice it, you get 0, 3. Okay, next, we're plotting the point that has the given polar coordinates on the graphs below for these two. So, given polar coordinates. So we want a radius of 5 and an angle of -120. So radius of 5, angle of -120. Well, positive 120 is right here. So -120 does the exact opposite, but it just goes 120 degrees in the opposite direction. So we'd be on this 240 angle, this line labeled with 240, and we go 5 units in that direction, so we count out 1, 2, 3, 4, 5, and there's our point right there. So that's the point, -5 or 5, -120. Okay, next we got -3 pi over 4. Remember, a negative radius takes you 180 degrees or pi radians opposite where the angle actually is. So if we go to 3 pi over 4, that would be right here. But instead of going 3 in that direction, since it's negative, we would go 180 degrees to the other side over here to 7 pi over 4 and go 3 in that direction. So we go 1, 2, 3, and there's our point right there. Okay, so for this last one, we are identifying our classical curves as our circle, our rose, our cardioid, our lemniscate, our lemnicon, and our spiral of Archimedes. All right, so for this one, we've got, so consulting our formulas. So when it's r equals something cosine n theta, this is our rose. This is our rose. So we know that's a rose. Because remember, the general formula for rose is r equals a sine or a cosine n theta. Where a is just some number. So that's how we know it's our rose there. Okay, r equals 3 theta. When you've got r equals theta, or r equals some multiple of theta, that's our spiral of Archimedes. It's our spiral of Archimedes. And remember, because it's basically just a circle or some kind of curve where the radius just gets larger and larger the more you go, which makes sense why, if you were plotting this, the radius just gets larger and larger as you go. So that's why it makes that spiral. And remember, that's just r equals a theta. So any multiple of theta, that's a spiral of Archimedes. Lastly, we've got number 20, which is our 3 plus 6 sine theta. So notice it's not r squared or anything, so you can, it's not the lemniscate. It's either the lemnicon or the cardioid. But remember, the cardioid, these two numbers have to be the same. So it's not the cardioid. So this must be our lemnicon. And remember that formula is r equals a plus or minus b sine theta or cosine theta, one of the two. That's our lemnicon. So remember, when these are different, it's a lemnicon. If these had been the same, if it was a plus or minus a sine theta or cosine theta, that's when it's our cardioid. So we talked about the rose, we talked about the cardioid, the lemnicon, the spiral of Archimedes. Remember our lemniscate, what this one is, just for future reference, it's r squared equals a squared cosine 2 theta. Cosine or sine 2 theta. So that's the one that's squared. And then our circle, the circle is the one where it's just r equals a. So r equals just a constant, or r equals some constant sine theta. So either a cosine theta or a sine theta. So notice how the cardioid and the lemnicon and the cardioid both have, they're the only ones that are some constant plus or minus your term with sine theta. If there is no constant at all, basically if the a is gone and it's just the b sine theta, you know it's your circle. If there is no sine theta at all, then it is your spiral of Archimedes. And for this one, the main difference between a rose and a circle is just that you have n theta. You have a constant inside of the parentheses next to the theta. And that's how we know a rose versus a circle. All right, that concludes the podcast on the Chapter 9 test review.